In this video, we'll be looking at the ideas of forces and momentum. So firstly, what's momentum? Well, momentum is, to put it plainly, is the quantity of motion of an object. And this is shown with the equation P equals mv, where P is momentum, m is mass, and v is the velocity. So, another feature of momentum is that it is always conserved in an isolated system. This means that the sum of momenta before and after a process will always be the same. So you could have both masses added up, and then there'll be a new velocity. So it's always conserved, basically. Now, so as you can see here, this is momentum of one object and this is of another, and in this example, the process that has occurred is that there's been a collision, and they have coalesced or joined together, and therefore there's a new velocity. From this new information, I'd like to be able to do a question. So let's take two objects. Object 1 has a mass of 5 kilograms. Object 2 has a mass of 1 kilogram, and its initial velocity of object 1, or the initial velocity of object 1, is this vector here, meters per second, and velocity of 2 is 0. So the question asks, what is the speed of object 2 if object 1 travels at the vector 2, 1 meters per second, and they don't coalesce, which means stick together. Okay, so that's the question. It's asking for the speed, so we might have to do a bit of Pythagoras actually near the end. Okay, so let's just set up from the conservation of momentum. We can decide that object 1's momentum plus object 2's momentum equals object 1's momentum afterwards plus 1 times this new velocity, or the new velocity vector that that's unknown. So what we can do is actually take two simultaneous equations, one in the I direction, which is going right. Let's resolve in the right direction. Now velocity arrows look like that. So 15 equals 10 plus Vx, and resolving upwards, 20 equals 5 plus Vy. So from this information we can work out Vx equals 5, and then Vy equals 15. But we actually want the speed, so speed of m2 equals the square root of 5 squared plus 15 squared, which equals the square root of, so that's 225, that's 250, which equals 5 root 10, which equals, sorry, I'll just quickly get the calculator, which is approximately 15.8 meters per second. Next, I want to introduce you to forces, or force. So one way of saying force, or explaining what force is that it's the change in momentum over the change in time. It's the derivative, I suppose, if you want to go for the maths route. It's the derivative of momentum of an instantaneous force. Another way of saying it is that it's the quantity required in order to accelerate a mass of m to to an acceleration of a. Well, in order to accelerate by the rate of a. So one thing that forces have, like all vector quantities, is that the resultant force is the sum of all the vectors. So, for example, if that was 5 newtons right, 3 newtons down and 2 up, that'll be equivalent to 5 newtons that way, and then 1 newton down, which is also equivalent to saying, what's that for? Root 26 newtons that way, in that direction, which is root 26, that's 5.1. So yeah, so using this information, I'm going to show you a problem with forces. So let's draw a diagram. It says that an object of mass 2 kilograms is tethered to 2 ropes which hold it up, and the forces are in equilibrium. One rope is at 50 degrees to the horizontal with a tension of 20 newtons, and the other rope is at 30 degrees to the horizontal. What's the tension in that rope? So let's draw a diagram. Let's use the information here. As my maths teacher always used to say, and still does, don't be a wretch, draw a sketch. So, you know, pretty much words to live by. So this one's 50 degrees, and it has a tension of 20 newtons here, and this other one has that's 30 degrees, and then unknown tension here. This mass is 2 kilograms, so its weight is 2 times g, otherwise known as 9.8 meters per second squared. Okay. So let's try and work things out. We want to resolve again, because you can see here that we're going to have to take two, like we're going to have to use components of the forces because it's angles and such. So let's resolve upwards with our forces. So this is going to be t times by sine 30. Actually, this is added on to 20 sine 50, and then that's going to be minusing by 2g, because that's the opposite direction. And as the forces are in equilibrium, there's no mass times acceleration. There's no acceleration going on here, so that's just 0. Okay. So sine 30 is a half, so you can just say t over 2 plus 20 sine 50 equals 2g, and then that's equivalent to saying t over 2 equals 2g minus 20 sine 50, and then finally we can say t equals 4g minus 40 sine 50. So t equals, let me just get on my calculator here. Alright, so that's 8.56 newtons. So therefore, tension in rope is 8.56 newtons.